Okay, identify and classify numbers according to the real number system. This is the way we count. It is important only in that you need to understand how we count things, because it's going to depend on, or it's going to make differences in the way we graph things. Okay? So first we'll start with just defining them all. Does anybody remember what a natural number is? 1 and up. It's how we count. Okay? So natural numbers is how we count. If I say, hey guys, let's start counting, one nerd in the class is going to go 0, 1, 2, 3, and all 29 of the rest of us are going to go 1, 2. Do you understand what I'm saying? Okay. So natural numbers are how we count. 1 up to what? Infinity. Right? How many of you, when you were kids, decided to try and see how far you could count? Thank goodness there's at least 2 of you in here. And how many of you gave up? The furthest I've ever counted in my life is 2,994. Then I stopped counting.
You weren't willing to get to 3,000?
No, it was because I was doing the Tough Mudder and I was counting my steps. And at the 3K mark, as I crossed the 3K line, I was 2,994 steps, meaning my steps were almost exactly a meter.
On a plane ride to England, I counted to like 7,000, and I was like, I can't go any farther.
I know, it's lame, right? Yeah, you just, I'm going to count. And kids think it's awesome. Like, I remember my kids growing up, Dad, I can count to 100 now. Good job. And you got to be nice, right? Like, way to go. Dad, I counted to 712 last night. Awesome. So really, you can count to 7. But you don't say that to them. You stop at awesome. So anyway, 1 to infinity, how we count. What isn't part of the natural numbers? No decimals. Don't say whole numbers. Let's just do this. No decimals. No negatives. No fractions. Which makes this technically the smallest set. Right? Even though it goes to infinity, it is still the smallest. Everybody with me? Okay. It has an abbreviation. Okay? And you would think it was N, Ranveer, but it's not. It isn't. We'll come back to that in a minute. Whole numbers are the naturals plus what? Naturals plus 0. So it's 0 to infinity and all the same rules. Right? Integers are the wholes plus what? Negatives. And it's negative infinity up to positive infinity. Same rules. Everybody cool? Right? And all of these have abbreviations. And it's not NWI. One of them is Q. One of them is, I don't even remember what they are. It's so stupid. So I will find out and research it for you and tell you what they are. Because I don't remember what they are. Because I learned it in 1991. I know, right? When I was in grade 11. And that was the last time I used it. Was on one test in 1991. So I'll find out what they are and tell you. Because I don't remember. And rational numbers. Now, rational numbers are what? Everything else except what Bryce just said. Rational numbers are all the fractions. Anything that is any number over another number. As long as y doesn't equal what? 0, and x and y are integers. So as long as you can make a fraction and the x and the y are both numbers, you have a rational number. The other thing is all repeating or terminating decimals. What does a decimal repeating mean? 3.333, 3.12345, 12345, 12345, 12345. Okay? As long as there's a pattern, that's still a rational number. That's repeating. What does a terminating decimal mean? It ends. How many decimals is it allowed to go to before it ends? As many as you need. You can have an infinite amount of decimals as long as you eventually stop. Understand? Well, it isn't actually that hard to prove, but it just takes time, right? 1 plus 1 equals 2, right? But technically for a math proof, it takes like 5 pages to prove that. It's stupid. Everybody cool with these? And then irrational numbers. Are everything else. Now, what is the most famous irrational number? These guys have been muttering it already. Pi. Pi is irrational because it never ends and it never repeats. Do we know it never ends and never repeats? We do not know it. We have computers that have been doing division of pi since the 60s. They're up to billions and billions of decimal places. It hasn't ended. It hasn't repeated. So we assume it will never end or repeat. Okay? But we don't actually know. And the other irrationals are all the square roots that aren't perfect. So the square root of 2 is irrational. Square root of 3 is irrational. Right? Square root of 4, that's okay. Square root of 5 is irrational. Now here's where we get into trouble. Is the square root of 2.25 okay? That's the square root of 225 over 100, yes? Which is the square root of 225 over the square root of 100, right? What's the square root of 225? 15. What's the square root of 100? 10. Are those both integers? So is it rational? So is that rational? Yes. Everybody understand? That's all review from grade 10. That's all cool for everyone, right? Yeah? What?
You said that would be rational.
Yes.
Yeah, not irrational.
Yeah, that is rational. Most people immediately say irrational because of the decimal.
Yeah.
Right? And then I do this to you. Okay, what about this? Square root of 22.5. Is that rational or irrational? It looks the same because it's got the same digits. Is it or isn't it?
As far as I can tell, it's irrational.
It is irrational. Yes. Because that is really the square root of 22.5 over 10, yes? Neither one of them has a square root. Picking up what I'm putting down? Everybody good with rational and everywhere else? Okay. Tomorrow, I'm going to get you to do this activity, but we're going to do it tomorrow after you've had to think about it for a day. What? Negatives can't have a square root. So they're irrational, right? Actually, they're imaginary numbers, but we'll talk about them. We won't talk about them. You'll talk about imaginary numbers should you take Calculus 12. It's not a pre-calculus thing. All right. So we are going to do that activity tomorrow, but I want you guys to do this right now because there's some tricks there. Do A through G. We'll talk about the next thing in a minute. You can talk to each other. You don't need to be silent. You look like a giraffe. Yeah, whatever they are. But remember, if something's natural, it's automatically everything else, right? Is the square root of 25 a natural, a whole, a rational, or an irrational?
Can you go back to the rational thing? I missed it. Oh, do you know how to check if I'm calculating on the right thing?
For trig?
Yeah.
Yep. Push mode.
Okay.
Now look, I think the third line down says degree or radian.
Yeah.
Which one is highlighted?
Degree.
That's right.
Okay.
Yes? Okay. Does negative 14 have a cube root? No. So that must be irrational. What is the square root of 25? 5. So what is the smallest group that 5 fits into? Natural. 5 is natural, which means it is automatically what? Everything else, except irrational. What about that? That's a trick. Why is it rational, Jessica? Because it doesn't repeat, but what does it do, Kelvin? It ends. So it's rational. Did you say rational or irrational? Yeah, I thought so. D. Natural. Why, Bryce? Because it's positive 16. Yeah? 9.
Irrational.
That's an irrational answer. F. You want to say irrational, right? Because there's no such thing as a square root of a negative. But what is it really? I told you. What is it, Lucas? It's imaginary. Non-real, that's fine. Have you guys ever seen that shirt where it looks like this? It's got the square root of negative x and the this and pi, and the square root of negative x says to pi, be rational, and pi says, get real. Get it? Oops. It's total math nerd joke, right?
Such a niche joke.
Yeah, but there's 30 of you in a math class right now, so I have an audience that gets it. It doesn't go over well on the rugby pitch. There's another one I like where it's two atoms, and one says to the other one, I lost an electron, and the other one says, are you positive? That's a good one, eh? Chemistry joke. What about that one? Do you know what that one is? Technically, no, but what is your best guess? Irrational? Rational. Why? Because it repeats. But what if 300 decimal places down the road it goes 1/7? Right, exactly. We don't know. Everybody cool? Okay. Now you've had a bit of practice with it. Do that. I'll put the right answers up in a couple of seconds. You don't have to be mean and do your subtraction. Or you could to challenge yourself. This one I want you to do alone. Don't talk to your neighbor. Try it yourself. Hey, giraffe boy. Did anybody in here, I'm sorry to interrupt, I just found these yesterday. Did anybody in here lose a baggie of braces elastics? Okay. Because it'll help me.
Probably.
My kids don't even have braces yet. They'll get them though. My daughter's all snaggletooth. Well, they're like this big.
Yeah, it's like sniper shots, dude.
Headshot, gotta kill. How many confirmed kills? What's that? Hey, 5 pesos.
What's that?
It's worth like
50 cents.
50 cents. Estados Unidos Mexicanos. I don't even know if it's that much.
Peso is like less than a cent.
I don't know.
I think it's a tenth of a cent almost.
This has got a $5 sign, but dollar signs aren't paid. I don't know. All right. First row, where's the only tick go? Rational. How many people got 1 point? Yay! Where do all the ticks go for 10? Everything but irrational. Yay! Ooh, square root of 81. Where's it go? Same again. Yay! -2. Tricky. Integer and rational. Not whole. Oh, Joel. -1.5. Oh, barf.
Rational.
Rational only. 0.215. Rational only. Pi. Irrational only. 0. Whole. Integer. Is it rational? Is 0 rational? What's that? Is 0 an integer? Is 7 an integer? Is that an integer over an integer? Is the denominator a 0? So, is 0 rational? Yes. Woo! That you can't do. That's why it's not rational. What about 0.15? 155. Irrational. Do we know for sure? No, but based on the information we have there, that is irrational. Why? Because it doesn't repeat. It goes 15155. Square root of 3? I'm kind of giving it away with where the red dot is. Irrational. -8.1. Rational only. -153. Integer and rational. 3.14. Oh, I didn't fool anybody. Nobody went over here for irrational to tell me 3.14 was pi. Good. That saves me from stabbing my pen in my eye. Huh? And 23 over 8. Rational only. How'd you do? Did I fool anybody? Did anybody make any mistakes? But you're going to fix them now, right, Jessica? Good. All right. Next. Go. True or false? But you are in grade 11 now. If it's false, fix it. No more flipping coins. If it's false, provide a counter example. Make it true. You can talk to your neighbor. You don't need to do this on your own. All natural numbers are integers. True or false? Yes, yes, yes. You would have to fix it.
You ever watch a video of like mechanical calculators divided by 0?
No.
Really amusing. They just don't stop.
Oh, yeah?
They just keep going. It's really loud.
I'm reading this neat book. You might actually like it, Bryce. It's Galileo discovering the moons of Jupiter and Copernican theory and everything with the telescope, right? But the premise of the book is he's given the telescope by a guy from the year 4000 who has gone back in time because he needed Galileo. It's really crazy.
This is like, this plot went really deep into quickly.
Yeah, it's really cool. You might dig it. It's called Galileo's Dream. Okay. Are all natural numbers integers? True or false?
Yes.
Or, sorry,
It's true.
sometimes I skip questions.
All integers are rational numbers. True. And finally, all whole numbers are natural. False. How do I make that true?
Switch whole and natural in the sentence.
You could switch whole and natural. All natural numbers are whole. That would work. You could say except 0 and all negatives, right? Because negatives are still whole numbers, right? Okay, everybody is good? Everyone understands the number system? Can I never talk about it again until the 4th unit?
Talk about it again.
Do we have to?
Just go over it again tomorrow.
Tomorrow I'm going to give you an activity. You're going to walk in and say, do this activity. And that's all I'm going to say. And I'm going to see how many of you do it properly. Okay, good. I can stop talking about it. I hate it too, Sydney, but I do have to get it out of the way because it does come back to haunt us in Unit 4. Now, exponents. I don't know about you guys. I don't know about your grade 10 class, but the grade 10 class I just taught stunk up the joint at exponents. I don't know why. What does 7 to the third mean? 7 times 7 times 7. You are all in pre-calculus 11. At some point this semester, one of you is going to tell me 7 to the third is 21. One of you is going to do it. It's not that you're unintelligent, but you will tell me 7 to the third is 21. Every year somebody does it. Every year I do this speech, and every year the whole class says, won't be any of us. Or they do this thing where they look around and they try to pick who's the doofus that's going to say that. One of you is going to say that. And it's okay. It's okay. But please don't. What's the real answer? 343. Obviously. What's the base? 7. Okay, now guys, one of the biggest problems that I notice with this is all of you can tell me that 7 is a base, right? The thing that messes you up is what I'm about to write now. A base is anything anything to the left of an exponent. It can be a letter. It can be a number. It can be a coefficient and a variable. Okay? It is whatever is immediately to the left. Okay? Where you guys get screwed up is this question. What is the base there that I just wrote in blue? 4x. Both of them. What is the base now? Just x. That is something that causes much grief. Okay? So make sure you are comfortable with that difference. All right? The exponent is what? 3. And the exponent is, again, anything that is a superscript. Superscript means it's written above the line. Okay? Can it be a variable? Yes. Can it be a coefficient in a variable? Yes. Can it be an entire expression? Can I write this? 3 to the 2x minus 1. Yes. As you go further in math, you will learn how to solve those. You will not learn it this year. Some of you already know. Okay? What's the power here? No. The 3 is the exponent. 7 to the 3. The whole thing is the power. And it's read as Sydney just said, 7 to the 3rd. What are the special names? There's only 2. What are they? What would we say instead of 7 to the 2? Squared. And 7 to the 3? Cubed. Nobody else gets a special name because we only think in 3 dimensions. Okay? That's not true. We actually have more dimensions. It depends on the physicist you ask. Some physicists will tell you there's 70 dimensions. I don't know. I'm happy with length, width, and depth. No, I don't want time as a dimension because that then limits time to being limits time. I don't want to limit time. Are we? I don't know. Elon Musk says we're not existing. Elon Musk says there's about a 1 in a billion chance that we are not a computer simulation like the Matrix. 1 in a billion, which he figures that means 999,999,999 times out of a billion. We are a computer simulation. But that guy's rocket blew up. What does he really know? Right? I mean, come on. Yeah. All right, you guys should be able to fill this in your sleep, right? Go. I'll be filling it in up here. You can check every couple of minutes, make sure you're doing it right. Please check after the 3rd one to make sure you have remembered your bases and exponents correctly. And then somebody with a calculator has to do the 4th one because I'm too lazy to get my calculator out. $568? Yeah. 768. Thank you. And the next one is something like 7,000, isn't it? Yeah, 7,000. Right. It's fine. Don't. But remember, don't complain when you do your exponents wrong. That's all I'm saying. There's a reason I make you do the repeated multiplication. Because I've marked 1 million tests, and too many people screw it up. There's a lot of different answers for these two. That was a stupid color to use. Shut up, Joel. On a real projector, it would have worked fine, but this one, because I'm a second-class citizen, so nobody brings me a new one. It's hurtful, Jessica, let me tell you. It is. Oh, that's true. I actually eliminated, I got rid of the ability of this thing to use a finger because I got fat fingers and I would keep touching it with my knuckle over here. So I'd be writing over here, minding my own business, and all of a sudden it would jump over here. Ah! All right. Sorry. All right. Everybody remembers how exponents work, yes? Honestly? That's where I want to end then. The bell is about to go.